Okay, class. So this is EM waves, which is the chapter 8 of your NCRT first book. Okay, this is the chapter 8. So NCRT part 1, this is the last chapter that is left. Mariam and Khadija, please. Okay, Mariam is using the data, I understand. Khadija, please open the camera. So see, uh, EM, EM stands for electromagnetic. And see, this whole book is about electromagnetism only. In the initial part, in the initial 3 chapters, you talk about this electro part. Then in the later on of the segment of the chapter, you study about the magnetism part till the 5th chapter. And then after that, you have entire combinations. EMI is a combination, AC is a combination, and now EM waves is a combination. So class, study this chapter. This is a suggestion. See, this chapter will be when this chapter will be done. So you will have the whole electromagnetism spine with you. So go brick by brick, one chapter like this, because then you will feel everything connected. So it's a good way to revise in that manner. And then EMFs is an easy chapter. It has the easiest numericals. Yeah, those students who cannot memorize well, they will be facing a little difficulty because you have a spectrum whose frequency, wavelength, all those definitions, the applications, the usage that you have to remember. तो हाँ, वो तो पूरा रटना पड़ेगा. So जिसको उसमें प्रॉब्लम है, जो याद नहीं कर पाता, उससे प्रॉब्लम होगी उसमें. So you have to learn it, that part. But that I'll discuss also. But I'll share a table. In that table, it will be a little better for you to learn. Though I'll prefer if you refer to NCRT. Okay. So this is electromagnetic. And waves, you have had a touch of waves in already in your class 11th, though you have wave optics also, and there we'll be studying about the entire mechanics of waves in detail. So when we say electromagnetism, electro part, you all know that this stands for electric field. So your concept of electric field should be clear among the entire electrostatics. And similarly, for magnetism, you need to have a good knowledge about magnetic field. Electric field and magnet. See, we will be talking about something there's a term time varying. Time varying means something which is depending upon time. As the time is changing, that quantity is also changing. So a time, we will study in this chapter that a time varying electric field. A time varying electric field means not a constant one. Electric field is not constant, it is depending upon time. The entire alternating current we have studied and everything, we have seen that time has a very huge impact on every physical quantity, right? So a time varying electric field produces magnetic field. Okay, it produces magnetic. Means constant electric field we are not talking about. Time is equal to 0, you have 5 Newton per coulomb of electric field. Time is equal to 10 seconds, you have 20 newtons per coulomb of electric field. That is a relation between these. But this is not the only criteria you can say. When you have a time varying magnetic field, so does it also produce, when you have a time varying magnetic field, so the question is that does it also produce electric field? So yes, these questions, that current and magnetism, how they are related, that has already been solved in the EMI, Faraday's laws of EMI, and we had clearly seen that yes, both of these cases are possible. So yes, definitely it will be producing an electric. Now, how they are producing and how they are being produced, that is the best way to study it with the help of a graph, and that graph is very important. So first you write down this, then I'll start with the graph. Okay, see class, this graph is very important. You have to plot three things: electric field also, magnetic field also, and the wave also. Means what we are going to do, we are going to plot electric field on the y-axis. This, okay, and magnetic field we will plot on z-axis. Let's take z-axis. And the direction means direction of wave propagation, where the wave is moving. Wave will also be moving, the electromagnetic wave. So this will be along x-axis. Okay, so let us start. Yeah, first electric field. Electric field is along y-axis class. So you have, I'm starting from the origin, but my direction should be along y. Now electromagnetic waves are also sinusoidal waves because it is time varying. So you cannot draw a straight line or a linear straight line like this. No, it is not a constant. So for variable, you have the sinusoidal wave as the perfect, and you will be having sine in your formula also. So it is a sinusoidal wave. Electromagnetic waves, they are oscillating sinusoidal wave. Basically, they are the energy transferring, each and every particle transfers. That I'll be talking. I just want to give you a rough idea first with this. Then we will come to all the waves. Don't worry. So electromagnetic wave, if I am plotting, so straight away electromagnetic wave will look like this. This will be how it will be plotted. Okay. So what is happening? Each and every particle from the base, it is going up. Look, from the base, it is going up. This is the amplitude. All these are the amplitude. And what is the maximum amplitude determines everything. See, E naught, which I'll be using, will be the maximum value out of these are the displacements along y-axis. All these are the displacements along y-axis. So out of these, which is the maximum displacement will give me the not attitude, the amplitude. Okay. So these are all the displacement of the wave. Let me remove this extra part. Okay. Then let's plot the magnetic field also. So what is this? This is the electric field that has been plotted. It's the electric field. Now magnetic field is along z-axis. So this is like this. Okay. Now how is the displacement of every particle occurring? Like this. See, perpendicular to the y-axis, like this. Every particle is oscillating like this. This is going up for these along the z-axis. Like this. And what about the wave? Wave is straight directly propagating along the x-axis. So this is the magnetic field, which is B, and this is the direction of propagation. Direction of propagation means the movement of the waves, propulsion of every particle. Okay. So this is propagation of the wave. So all these three are perpendicular to each other. Look, electric field, magnetic field, and the direction of propagation, all these are perpendicular to each other. It's a very important point. And this is the direction. Three things are present, all are at an angle of 90 degrees. Okay. Now coming to this equation. This is a set, don't write down anything, class, please. Yeah, Khadija, open the camera also. Now, this is the equation that we have. This equation we'll be using the whole time for the electric wave and the magnetic wave, both of the waves. So no need for any derivation for this, nothing, but you have to understand the meaning of each and every quantity which is present here. So let's go one by one. Let's give it a little time. What is E? This is the equation how we write. E is equal to E naught sine kx plus minus omega t. So let us understand this further. E is the electric field. This is very easy. E is the electric field. What is E naught? E naught, I think this also I have told you that it's the amplitude of the electric field. Okay. Amplitude of electric field. Or you can say the maximum value. Okay, this means the maximum value. Maximum value means if this is the graph which is plotted, so this becomes the maximum value, whether it's from your x-axis or from your y-axis. This is the maximum value just possible. That is E naught. Anything which has this symbol not in the waves, especially, is that. Okay. Now, what is this K? K is basically a constant that we use. Whose formula anybody knows? This was there in class 11. No one. In class 11th, you had these formula. 2 pi by lambda. Formula is 2 pi by lambda. Yes, Rishita, you're there?
Yes, ma'am.
K is equal to 2 pi by lambda. What is this lambda? This lambda is basically the wavelength. Wavelength means the length of one single wave before it begins with the repetition. Now see, after this, it will repeat. So only this part is the wavelength. That is what is meant by the wavelength. This, it can be X, it can be Y, it can be Z, it can be written as anything. This will be representing the axis. Now, which axis? There are three axes. The direction of propagation, that axis, because we are now talking about the waves, where the wave is propagating. So if it is Y, then it should automatically come to your mind that direction of propagation is Y. That time electric field will either be Z or X. They can never be parallel. So never make any two of these in one axis. Electric field and magnetic field को कभी x axis में दोनों को साथ मत कर देना. Both are plotted perpendicular to each other. Okay. Now these plus minus, this part, this is also very important. Plus minus part. So basically this helps us tell the direction of wave of propagation, that is clear through the x-axis. Basically, which axis? Now, when we have these three axes, x-axis, y-axis, z-axis, we have three types of axes, right? And among that also, we take positive, negative, right? We take positive, negative. So now how will it be determined? Suppose I write this equation, E naught sine kx, this. So you get to know only that this is x-axis. Whether it's positive x-axis, negative x-axis, that is given by these symbols. So these are not just for your addition or subtraction. These are telling you the direction of propagation of waves axis. If you have plus sign, then class, the problem here is that what you see and you cannot remember it like this. Means if it is plus, it is along positive x-axis. No, it's opposite. Okay, so when you are remembering, just remember it like this. Yahan par ulta tha. Okay, here we had it opposite. Plus was along negative like this. So you have to remember like this at this point, because this is along negative axis. If you have plus sign present in your equation, then it is along negative axis. So then if you are asked, if I give you this equation and I write plus sign, not just this minus, and I ask you which axis, where is the direction of propagation? So your answer will be negative x-axis. If I write plus, and if I write minus, then it will be along positive axis. Now, whether it's x, y, z is determined by the quantity next to angular wave number. This is angular wave number. This is called as the angular wave number. Okay. And this is telling you the direction of propagation. This is telling you the direction of propagation. And you are already familiar with omega. Omega is the angular frequency. So this is that same omega. This is the angular frequency whose relation with linear frequency is very important, because in the questions you have linear frequency given 50 hertz, 100 hertz, 200 hertz. So hertz is the SI unit for the linear frequency. So omega is going to be 2 pi nu. Okay, 2 pi nu. And yes, if you have linear frequency, it will relate it with time period also. Because what is the small t? Small t is basically the time. So linear frequency can be related with 1 by t. Okay. This linear frequency is equal to 1 by t. So when you are calculating angular frequency, sometimes you have to write it as, when you are calculating this linear frequency, you can write it as 1 by t. You can write it as omega by 2 pi also. Okay, wherever which is mentioned, whatever quantity is mentioned. Okay, 2 pi is necessary. So this is important. This is used a lot. This formula of angular wave number is important. These things are asked separately. One equation will be given. Some equation, E is equal to 5, 10x minus 40t, like this. Tell the wavelength, like this. So wavelength from this formula, you have this as 5. 5 is equal to 2 pi by lambda. Calculate the value of lambda. So that's why understanding of this equation is very important, and I have given a lot of time for just understanding each and every variable. If you have an equation for magnetic field, I'll not repeat everything. It's just a wastage of time. But you should understand B will now be representing magnetic field, and B naught will tell you the amplitude of magnetic field. Rest of the things you can see it from above. They are the same. Values are the same. This bracket. Same rule, everything is same. You write it till here, then we'll see the definition of what exactly is EM wave. Write it, class, and mark all this important. Okay, if completed, you all can leave. We'll continue this in the next class now.
Thank you, ma'am.
Yes, Shaima, you had some doubts?
Yes, ma'am.
Yeah, okay. Please share the questions on WhatsApp, or if you have a portion to study, please tell.
Ma'am, I just have doubts in specific types of questions from different chapters.
Okay, share the questions, Shaima.
Okay, ma'am. Ma'am, can you give me your number?
Share it with the Learnivio's teams. Shaima, they'll forward it to me.
Okay, ma'am. Ma'am, I sent it in the Zoom chat because Learnivio did not see the message yet.
You've sent it on the WhatsApp?
Yeah, I've sent it to them on the WhatsApp. Also, I've sent it in the Zoom chat.
I think it's not very visible from here. Let me just download it and check. Okay, just wait. See, this question says, the first question I've downloaded that. It says the body covers first 1/3 of its journey with speed u. Next 1/3 means we have to divide the total. We have to divide the, just a second. Just a second, Shama, that the screen is hanging. Just wait. Let me just cross it and open it again.
Okay.
See, in this question you have, it says that a body covers first 1/3 of its journey with speed u. Means, see, we have to divide this entire into 3 parts, okay? So the first part which is present, this says that this is covering 1/3 of the journey. Means let's say the total journey is 3x. So first x part, this has the speed u, the second has the speed v, and the third has the speed w. We have to find out the average speed, right? So see one thing, if the total distance is x, I am assuming it to be x. So when you have the journey getting divided, so this will be x by 3 because you are dividing it. This will also be x by 3 and this will also be x by 3. So these are the two edges, x by 3, x by 3, x by 3. Now in the first part, you will solve this also in 3 parts. So in the first part, see, 1/3 distance is there with the speed u. So what will be the time? Because see, for average velocity, what do we need? For average velocity, we need the total displacement by the total time. Total displacement is there x, but what about the total time? Total time is not there. So time is distance by speed. So what is the distance here in the first part? X by 3. And the speed is u. So x by 3u. Now, similarly, when you are talking about the part 2, so the time here, this is t1, the time here t2 is, again, distance. What is the distance? X by 3. And what's the speed v? Similarly, the part 3, just understand first, Shama, then you can copy it. This is x by 3 into w. You have all the time ready. So what's the average velocities formula? Total distance is x by total time is x by 3u plus x by 3v plus x by 3w. Firstly, all the x will be cancelled. And let's take the LCM, even if we have 1 from here. LCM is going to be, this is 3 u v w. You will multiply all the digits that you have. So here in this 1 by u, v and w are missing. So this is uv plus vw plus uw, and this goes up. So your final answer here is 3 uvw divided by uv plus vw plus uw. Okay, clear?
Yes, ma'am.
Please write it down.
Ma'am, can you scroll down? Done, ma'am.
Okay, your second question. It says that a car travels first half of the distance between two places at a speed of 40 kilometer per hour and second half at 60 kilometer. You have to find out the average speed. See, you know, time is equal to distance upon speed. So when you have, now we are going to divide it into two. Okay, this will be it. So again, when you have the total distance, firstly, let's say that distance is the, let's take 2x as total, so that we are saved from that fraction thing. 2x is the total distance. So each half will be x. Because in the previous question also, if we took it as 3x, it would have been a little easier. But the answer is same in any of the cases. So this is 2x. 2x is the total distance, and here the speed is 40 kilometer per hour. And this is 60 kilometer per hour. So again, if we are calculating the time 1, it is x by 40. When we are calculating the time 2, this is x by 60. And for the total distance, again, when you're calculating the average velocity, it is total displacement by total time. Total displacement is 2x by x by 40 plus x by 60. So x is cancelled from all of these. So this is 120 and 3 plus 2, right? So, and 2 is also there. So 240 will be there above, and the denominator you have 5. So it's 5, no, 4, 8, 48 kilometer per hour. Same procedure. This question is even easier. Clear, Shaima?
Yes, ma'am.
Okay, write it. This is your question 2.
Done, ma'am. Done, ma'am.
Okay, Shaima. Then I think your doubts are clear.
Yes, ma'am. Ma'am, also, can you explain the spring part
Which part?
from chapter 5?
Mm-hmm.
The
Which part?
potential energy of spring.
Okay. See, in the spring mass system, when the spring is at rest, see, one end of the spring is attached to a rigid fixed surface, other end is free. So when you are not touching it, the resting surface, the resting position, that is called as the mean position. And when you stretch it or you compress it, so this displaces the body away from the mean position. See these three cases. This is the normal case. You have extended it, you have compressed it. So whether it's extension, whether it's compression, this separation from the mean position, it is taken as x. This is the distance. And see, due to the external force, whether I am pulling it because of my muscular force, which is acting as the external force, any device is pulling it, anything, that is the external force. And I have told you also, when any force is there out of the system, it is called as the external force. But see, there is an internal force also, that is the restoring force. It develops as you pull the object away. It develops as you compress it or you extend it. And the restoring force has a property that it will always try to push the object towards the mean position. If you have extended it, direction of restoring force in this example, it is towards the left. But if you look at this example, direction of restoring force is towards the right. So like this, the direction of restoring force is always directed towards the mean position. So displacement, this force is directly proportional to the mean position. And the actual formula is F is equal to minus Kx. K is a spring factor, which is a constant. And for different systems, we have different values of the spring factor. So for spring mass system, we have the term spring constant. Means the spring constant, this is the spring factor or the constant term here. Now work done will be F dot dx. When you are stretching the spring, the work done is force dot displacement. So from 0 means the mean position to the extended displacement x, we are extending it.